Clearly, if I want to eventually hit only the uniform distribution on this set of minima, what do I have to do with these betas? I have to change these betas in which way? We have to increase them, right? With n, beta has to increase. So now comes the question that at what rate I should be increasing beta? Because you see, if I increase beta too fast, what will happen? So you will run into this problem of getting trapped into local minima. On the other hand, if you let it grow too slowly, then most of the time you are just doing a purely random selection and you are not getting close to the minima. So you have to balance, okay? So this term simulated annealing, that term comes now because annealing is what is called a process of slow cooling. So it has to be, so beta is reciprocal of the temperature in the thermodynamic model. Beta is reciprocal of the temperature. So when you are increasing beta, that's like cooling the system because temperature is going down, okay? And the cooling has to be slow. So the analogy that these physicists give is something like this. So that is why, so this term simulated annealing was not used by Cerny when he developed this algorithm. He was solving the traveling salesman problem, but the term simulated annealing was first used by Kirkpatrick and Gellert in their science paper. So it's actually a science paper where this algorithm first came, okay? And they used the term simulated annealing for the following reason, okay? So this term annealing is used in metallurgy actually. You know that these metals, if you heat them to a very high temperature and you immediately cool them down, they become very brittle, okay? But if you slowly cool them, they become more malleable and ductile. The reason is these molecules, when you slowly cool them, they gradually reach the ground state and that's sort of the optimal state, okay? So that was the idea or motivation from physics that was coming, and that's why they give this name annealing, but with this extra qualifier simulated, because it's not real annealing, okay? It's a simulated or statistical annealing, okay? So the rate that they were able to show, let me first give you the inhomogeneous Markov chain and then I'll discuss the rate.